In this video, we take a look at how to perform data binding between a collection of objects and a UI in WPF. This application demonstrates binding a collection of strings to a UI that is designed to only display one item at a time. It also demonstrates performing navigation by allowing us to navigate through the list of those strings. So in this video, we are going to be implementing this project following the MVVM design pattern. So with that being said, let's go to Visual Studio and get to the coding. Here in Visual Studio, I already have a WPF project set up. Now, since we are following the MVVM design pattern, which allows us to split the application into 3 layers, basically the models layer, the views layer, and the view models layer. Here in my project, I've got 3 folders, and each folder corresponds to a layer. So I'll be placing code in each of these folders based on the layer that the code belongs to. So what I have here, now here in the main view, we also have a view called the main window view, which is basically the main view of this application. This view consists of a border, and inside this border is a text block. Now here at the bottom, we have 2 buttons defined, and these buttons will be used to implement the navigation. Now, by the rules of MVVM, we need to place all the views inside the views folder. So I'll simply drag this main window view to the views folder. Now, since the main view is now inside the views folder, I also need to make a change to the app.xaml file. And that change will be made to the startup URI property. So basically, I'm going to indicate that the path of the main window view is inside the views folder. So I'll simply save this. All right. Now, to perform data binding to this view, we need to create a class that's going to contain the properties that will be bound to the text block here, as well as to the 2 buttons. So that simply means we need to create a view model. So I'll go to the view models folder, and I'm going to add a new class. I'll name this class main view model. So I'll set this class to a public class, and inside this class I'm going to define some properties. The first property I'm going to define is the collection of strings. So I'll simply say property, and this collection will be a list of strings. I'll name it letters, and I'm also going to create a property of the type iCommand. I'll name this one the move next command. I'll copy and paste, and I'll name this move previous command. So basically, these 2 commands will be bound to the buttons. Now I'm going to create a constructor as well. All right. Now WPF has got a class called the collection view source class. This class allows us to get a view of a collection. Basically, the view of a collection allows us to view the data of a collection in different forms. It also allows us to perform things like navigation and filtering, as well as sorting. Now, in this case, since we want to get the view of the letters collection here, I'm going to create a property and this property will be of the type iCollectionView. I'll simply name this property view. So we are going to get the default view of this letters collection here, and we're going to store it inside this view. Now this view is going to allow us to view the data of that collection as well as perform navigation on the collection without actually changing the data or modifying the collection itself. So I'm going to instantiate the collection. So I'll simply say letters is equals to a new instance of a string, of a list of strings, and I'm going to define those strings in here. Alright, so now that I have the list of strings, I can now get the default view of this collection and store it inside this view here. So to do that, I'm going to use the collection view source class. So the collection view source class has got a method that allows us to get the default view of a collection. So I'll simply specify the letters collection. Alright, now that I have this view of our letters, I can now perform things like navigation and filtering, sorting, etc. But for this tutorial, we are only going to be performing navigation. Alright, now for these two commands here, I need to create a class that implements the iCommand interface, and I need to set these to the instance of that class. So I'm going to create a command class, and what I'm going to do is I'll simply go to the root of the project, and I'm going to add a new class, and I'll call this class RelayCommand. Now this class is simply going to point us to actions that are going to be performed when the buttons are clicked. So what I'll do is I'll first start by setting it to a public class, and this class needs to implement the iCommand interface. Alright, now that the interface is implemented, we can see that we have two methods defined, canExecute and the execute method. So when a button is bound to an instance of this class, and when that button is clicked, it's going to first execute this method here called the canExecute method. This method will return a boolean, and this boolean is going to determine on whether the execute method here can be invoked. So what I'm going to do is I'm going to allow the user of this class to specify two methods by passing those two methods inside the constructor, and those two methods are simply going to be executed inside these two methods here. So what I'll do is I'll simply add a constructor, and I'll add in a parameter of the type predicate. Now predicate is simply a method that returns a boolean, so that method is similar to this method here. So it's going to take in an object type, just like this method here takes in an object. So this method is going to be called the canExecute method, and And I'm also going to add another method here of the type action. Now the action is similar to this method here. It returns void. And this action is going to take in an object, and I'll just name it execute. So once these two methods are passed in through the constructor, I would like to save them or store them so that they are accessible within this class. So to do that, I'll simply say underscore can execute is equal to can execute underscore execute is equal to execute. All right, now I need to create two fields. So basically properties that are going to allow me to access these two methods within the class. So I'll simply tell Visual Studio to generate a field for me. All right, so I now have these two injected methods available within the class. So when a button is clicked, this method is going to be called. So when this method is going to be called, I would just like to call the method that was passed through the constructor. And this is the can execute method. Remember that this is a predicate, so it simply represents a method that's going to return a boolean. So I'll simply call this method and return the result of that method. And I'm also going to pass this the parameter object. All right, I'll do the same for this method. I'll simply call the execute and pass it this parameter object. All right, so we're almost halfway done with this class. So basically, when an instance of this class is being created, two methods are going to be passed through the constructor, and those two methods are going to be called whenever the can execute is called and the execute is called. All right, now I'm also going to make a small modification to this event here. So this event is simply raised whenever the can execute is changed. So I'll simply say add. So simply when adding this event, also subscribe to the command manager's event, which is requery suggested. So simply subscribe to that and set it to the event. So simply set it to the value. Then I'm also going to say remove command manager simply beta as well and subscribe. Okay. All right, so this should do it. This is going to ensure that when this can execute is changed, that event is propagated and updated in the UI. So I'll simply save this. Now I'm going to go back to the view models class, which is our main view model class here. And for these two commands here, I'm going to set them to an instance of the RelayCommand class. So I'll say move next command is equal to new RelayCommand, and remember we are passing it two methods. So I'm going to define a method which is the can move next and the move next method. So one method here is going to return a boolean, and it's going to determine on whether we can execute move next. Now we do not have these methods defined, so with the help of Visual Studio, I'm going to generate the methods. Alright, so I'm going to start by implementing the can move next. So to determine on whether we can move next, what we're going to do is we're going to take our view and ensure that the current position, which simply means the current position of the item that's in view, does not exceed the maximum count of our collection. So basically, this method will prevent us from going beyond the collection. So to do that, I'll simply say, as long as the current position is less than the amount of letters that we have, so the letter count. Now remember that the letter count is an index, which means it begins with 0. So we need to offset it by 1. So I'll simply -1, and that should do it. So this is a comparison. It's going to return a boolean. So I simply say return. So to move next, what I'll do is I'll get the view and simply call a method, and that method is move current to next. So I'll simply call this method, and that should do it. So we are also going to do the same for the move previous command. So I'll simply say move previous command is equal to a new instance of the relay class, and the relay class is going to point us to two methods. So I'll simply say can move previous Alright, and move previous. Okay, so this simply means we have two methods again. So I'm going to generate those two methods. Okay, so we can move next. So I'll simply say return, as long as we are not beyond the first item here. So to do that, I'll simply get the view and say as long as the current position is greater than 0, then we can move next. So as long as the current position does not go below 0, then here simply say view, then move current to previous. So this should do it. Alright, so we have implemented the main view models class, so we can now perform some data binding. Now let's go to the main window view. So what we're going to do is we're going to go to the code behind of this window. So from the code behind here, we can set the data context of the window. The data context simply tells the window where to get the data from when performing data binding. So to do that, we can simply type this dot data context is equal to an instance of the main window view model. Of the main view model rather. Alright, and that should do it. So simply it makes this instance available inside our window. So if we come to the main window here, we can actually begin to perform data binding right from within the window, knowing that the instance of our main view model is available to the window, so we can do it in the code behind. However, this is just one way of doing it. We can also use a different approach, so I'll get rid of this. We can actually define that here in the XAML. So to do that, just under the window tag, I'm going to say window dot data context, and inside this we can actually specify an instance of the view model class. So I'll simply say main view model, and that should do it. So I need to add the namespace, so I'll simply add this namespace. All right, so our main view model is now available for data binding. To prove this, we're going to get rid of this text here, and we're now going to perform a binding. So I'll simply say binding. Now we are binding to the view property, so I'll simply say view. Then from my view, I would like to get the current item of the view. Remember, the view allows us to perform things like sorting, filtering, and also allows us to view the data of a collection in different ways. So I'll simply get the current item, and you can see the IntelliSense simply shows me the available properties I can bind to. So I'll simply get the current item, and the current item is the letter A. Now for the buttons here, I'm going to create some commands. So I'll simply say command. Then for this command, I'll bind and I'm going to bind it to the move previous command. So basically, when we declare our view model right here in the XAML code, it simply helps us to identify the available properties through the IntelliSense. So I'm going to bind a command. So I'll say binding, and bind it to the move next command. Notice how that it actually calculates and tells us that we actually can't move to a previous position because we are at the beginning of our list. So basically the logic is running right here inside the designer. Okay, so let's go ahead and run the application. All right, so the application is up and running. And here we can see that the previous button is disabled. Now this is made possible because we are using commands. When creating the instance of the command, we had specified two methods. One of the methods determines on whether or not that command can be executed. If the logic returns a false boolean, that means even the UI control will be disabled. So in this case, we can only move next. And once we reach our far end, we can see that the next button is also disabled. So guys, that's how you implement data binding of a collection of objects to a UI that's designed to only view one item at a time. And we can also navigate back and forth that collection. So guys, thanks for watching. The code to this project will be in the video description. I'll see you in the next one.